So we end this first unit with just some kind of basic word problems. I know word problems are difficult and sometimes a struggle. Okay, so I'm not minimizing that some of these are challenging, but they're not going to be the most painful word problems that we could design. So I'm going to do one, you're going to do one that's very similar, and then we'll see how it goes. So example one, this is just a pretty straightforward example of an addition problem. It says the painting of, that should be the painting on, I don't know that you would paint an easel, but you paint on an easel. The painting on the world's largest easel has a perimeter of 112 feet. Its length is 8 feet more than its width. And so what we want to do is answer the following question. What is the length of this painting? Okay, fantastic. So this is a problem that is based on addition, being able to add things up. In the first sentence, as you reread it, what's the key word in that first sentence? Perimeter. Yeah, perimeter tells you the relationship of what's going on. In case you don't remember your high school or middle school geometry, what does the perimeter mean to do for a rectangle? You just add up all the sides. Okay, so in case you didn't know that, make a note to yourself. Perimeter just means to add up all the sides. Other words that you might see for a relationship like this is the word total or sum, S-U-M. Okay, those are things that are going to tell you that you need to add stuff up. Okay, so here's what I'm going to do is I'm first going to write down that the perimeter is equal to 112 feet. Given a relationship between the sides, now I'm a visual person, so what I'm going to do in this instance is I'm going to draw myself a little rectangle right here. And I'm going to label that relationship. This helps me. If you don't need to draw a rectangle, if you're able to visualize it mentally without the picture, fantastic. That's a great skill to have. So here's the relationship. It says the length is 8 feet more than its width. So, which side should I call X? Okay, the width. The reason that we choose the width, in case that wasn't obvious to you or you didn't know that, the reason we chose the width is because once you know the width, we are told the length is 8 feet more than the width. Okay, the length is based on the width. So I have my width right here, X. So according to that second sentence, what's my expression for this side right here going to be? Okay, X plus 8 or 8 plus X. The order doesn't matter. Either way. Yes. I didn't hear what you said. I'm sorry. How do I know to use a rectangle? That's a great question because it's not actually stated explicitly that this painting is a rectangle. I think I will add the word a rectangle for next semester. So thank you, you're helping. But my assumption is that the painting is going to be a rectangle. So sorry, I will make sure to have great care that there will be no question on the test about what shape something is. Okay, great question, appreciate it. Okay, so let's add up my sides. So I'm just going to start at the top. What's the length of the top? Okay, X plus 8. Great. So now I'm going and finding the perimeter. I'm going to go over to the right. The right side is X. The bottom side is X plus 8. The left side is X, and that's equal to 112 feet. From here on out, I don't think this is going to cause any trauma. I understand setting up, getting the information out of the words and setting up, that can sometimes be a challenge. So practice just helps you get better at doing that. So on the left side of this, I've got 4 X's. 8 and 8 is 16. I'm going to subtract the 16 from both sides. And I think when I do that, I end up with, what's 96? That's what I'm going to go with, unless I'm told, somebody tells me I'm wrong. Divide by 4, and we're going to get that the X is 24. So just always answer the question. That is the last and probably most important thing to do. The question is, what's the length? Is the length 24? No, let's look at our picture. What does X represent? X represents the width. So to get the length, I'm going to take that 24 and I'm going to add 8 to it, and we get 32. So then to answer the question, it just looks like this. The length is 32 feet. There we go. And we're done with the problem. All right, example 2 is very similar, except this time it's going to be a triangle. I would recommend drawing a picture, okay? But give example 2 your best shot. Another perimeter problem. If you have a question, if you need me, wave your hand. I will come to you. I'll try to be as helpful as I possibly can be. All right, so I've drawn a triangle here, and I've labeled them long, middle, short, just so that I know which is which that I'm referring to, since in my triangle, it's not in the longest and the middle actually look kind of the same because I'm not a great artist. So there we go. So the first thing, the perimeter of a triangular plot of land is 2,400 feet. So again, same thing as last time, keyword perimeter. Perimeter establishes the relationship I'm going to use when I set up my equation. We're going to add everything up. So the perimeter equals 2,400 feet. Now this problem, it's a little more difficult to set up the relationship, so we'll read carefully. So the next sentence says, the longest side is 200 feet less than twice the shortest. Okay, so again, I'll ask the same question I asked before. If I'm going to find the longest side, what side should I call X? It says the longest side, to find the longest side, it's 200 feet less than twice the shortest. So which side do I need to call x? The shortest, yes, because the longest side is based on knowing that. And since I don't know that, I'm gonna call it x. So let's come up with an expression now. Propose for me what you think the expression for 200 feet less than twice the shortest side. What's that going to be? Okay. So twice, in case you didn't know, that means to multiply by 2. So 2x, twice the shortest side. And then 200 less than that means whatever that value is, whatever I get when I double the shortest side, I'm then going to subtract 200. Now, I know at least a couple of you probably wrote 200 minus 2x because that's the order of the words. I get that. Okay, but here's the problem. When you use the word less, okay, this word less says less than what I started with. That's just part of the intrinsic nature of this word. So when you use the word less, when you see that, that means I'm starting with twice the shortest, and then I'm subtracting 200. So this will not give you the right answer. So 200 minus 2x is the wrong order of those terms. All right, let's continue with the next sentence. The middle side, okay, is 200 feet less than the longest side. All right, well, let's come up with an expression for that. Because now I have an expression for the longest side, 200 minus 2x. So what am I going to do with this in order to find the middle value? Beautiful, well said. This sentence says the middle side is 200 feet less than the longest side. Well, the longest side is 2x minus 200. And then 200 less than that is going to be minus 200 more. Okay, we're just subtracting. Yes. That's exactly what it's going to be in just a moment, for sure. 2x minus 400. The key thing with word problems, I get it. I didn't like word problems when I was in your seat either, okay? But the way to get through it is to get yourself some experience with them, okay? So don't just avoid doing these, because when you leave this class and you actually apply math in other classes you have, it's going to be in the form of word problems and things that you have to translate, okay? So do as many problems as you can, okay, until you get good at seeing and being able to write down these relationships, these expressions. Okay, you can do it. It just takes some practice to be able to do it. So now the easy part to this is once you finally identify the relationships, the perimeter is 2400. So I'm going to take the shortest side, which is x, the middle side, which is 2x minus 400, as has already been told to me. The longest side is 2x minus 200, and all of that is going to equal 2400 feet. My perimeter is just adding up those three expressions that we came up with for the sides. So x plus 2x, that is 5 of them. Negative 400, negative 200 is negative 600. We'll now add the 600 to both sides and get 5x is equal to 3000. I'm just going through the solving because I'm assuming that we feel pretty decent about solving. You've done enough of it in your math lives. So if that is a bad assumption, we should talk after class, okay? Make sure that we get you equipped to solve equations, because we're going to solve lots of equations in this class as we go through the semester. When I divide both sides by 5, I get 600. X is equal to 600. So now I'm going to answer the question. The question that was proposed to me is to find the lengths of all three sides. Okay, so we've got one of them. The shortest side is 600 feet. The middle side, just going to use my expressions now. Well, when I take the 600 and I plug it into 2x minus 400, 2 times 600 is 1200, minus 400 is 800 feet. And the longest is, I take that 600 again and go to the longest side. The longest side is 2x minus 200. So 2 times 600 is 1200 minus 2, 1,000 feet. So on your word problems, just make sure you answer the question that is proposed to you. In the first one, we were just asked for the length. In this one, we were asked for all 3 sides. All right, we're going to flip the page. The second style word problem that you're going to be responsible for me is the mixture problem. Okay, so here we go. The mixture problem, in case you've not seen it, or in case you don't like it or haven't had much experience, I have a particular way to write this out. You are not bound to use the way that I do it. On MyMathLab, they use a table in order to set this up, but I like pictures, so I'm gonna draw a little picture. So here we go. Example 3. How much pure alcohol should be added to 20 liters of a 40% solution to increase it to a 50% solution? Okay, so you're in chem lab and you've got to make a solution for all the students. Maybe you're the TA or something, and you need to take the 40% solution you have on hand, you need to make it into a 50% solution for whatever is being done. Okay, so the drawing that I'm going to put right here, this works no matter what the problem is, whether what you're adding is pure or whether it's 80% or whatever. I'm going to draw 2 boxes. This first box is going to represent what I start with. Then I'm going to draw a second box, and this just represents what I'm adding. And then that's going to produce, so I've got an equal sign, that's going to produce my third box, what my result is. I do this for every mixture problem. So this works for me. If it doesn't work for you, when you go through MyMathLab, they will show you how to arrange things in a table instead, if you just prefer the Microsoft Excel way to approach this. Okay, so let's look at what I start. What do I start off with? What kind of solution? Okay, I got a 40% solution. So 40% of the liquid in this box is alcohol. The rest of it's just water. That's how alcohol works. You also see problems with acid because acid molecules are a certain percent of the water. So 40% of this box is actually alcohol. How much, what is the volume of this box? How much 40% solution do I have? 20 liters. Great, we'll come back to that. All I'm doing right now is I'm just taking the information the problem has given me, and I am just putting it into my picture so that I can do this problem. Okay, so this box represents my 40% alcohol solution that I had 20 liters of. Great. What am I adding to that? Pure alcohol, which is 100%. Okay, so this is a 100% solution. As I mentioned, if the problem is said you have an 80% solution, then you just put 80% here. This works no matter what the percents are. What's the volume of the 100% solution that I'm adding? I'm unsure. It says right here, how much? That's the question that I'm seeking to answer. So I'm going to call this X liters. I don't know how much it is. I know this is difficult. You got a question, ask it. Okay, you're going to get a chance to do something very similar in just a moment. Now, my result. What do I want my result to be? I want it to be a 50% solution. If I started with 20 liters and I add some unknown amount, what's the volume of my result here? I don't know, but I can have an expression for it. It's 20 plus X. I started with 20 liters and I added an unknown amount of pure alcohol. So I add those two things together. That gives me my final volume. Does that make some semblance of sense? Okay, so then here is how we come up with the equation we're going to solve. Okay, to me, that's the hardest part of the problem is putting everything down, getting the information out of the problem and putting it in the picture. Now what I'm going to do is I'm just going to think in terms of that alcohol. If I have 20 liters of solution and 40% of it is alcohol, how much alcohol, how many liters of alcohol do I have? How can I find that? 40% of 20. Yeah, so it's 0.40 times 20. Percents never work on their own. It's always a percent of something. So when you do the math, that's going to be 8. 8 liters of the 20 are actually alcohol molecules. The rest of it is water. Plus, well, the decimal for 100% is going to be 1.00 times x, because that whole box, everything in it is alcohol molecules. So each time I've just taken my percent times volume, percent times volume. On the other side, same thing, 50% of my volume, 20 plus x. Most common mistake students make on my test when I give it is not doing the percent times volume, just leaving the percent alone. Remember, percents don't operate on their own. It's always 50% of whatever you have. All right, the rest of this I don't think is going to be too big of a deal. So I just want to pause. Any question, anything that looks unclear right now? Okay, you're going to get your chance to replicate it. And remember, as I said before, the way to get good at this, the way to lock it in a long-term memory is to do several of them. Okay, even if it makes sense now, okay, remember our memories diminish until they get reinforced. So even if it makes sense now, practice it so it locks in. Okay, so 0.4 times 20, that is 8. 1 times x is just 1x or x. 0.5 times 20 is 10. And 0.5 times x is 0.5x. Personally, I don't mind working with decimals. They don't bother me at all. But if you want to avoid the decimals, let me just show you, just real quick, show you what to do here. So if at this point, if you're fine with the decimal, then you're going to bring the 0.5 over here and the 8, and then you'll divide, and it's all going to work out fantastic. But if you want to avoid decimals, like if you have a problem that has two decimal places, what do I have to multiply by each of these terms by in order to get rid of that decimal place? 10. Yeah, you could do 2 as well in this particular one, because 2 times 0.5 would be 1. But I'm just going to multiply by 10 to move that decimal place over. So I'm going to multiply everything here by 10 in order to get rid of the decimals. So if you want to practice decimal avoidance, this is how you would do it. So 8 times 10 is 80. 10 times x is 10x. 10 times 10 is 100. And 0.5 times 10 is 5x. That's an optional step. I'm going to bring the 5x over to the left by subtracting. That leaves me 5x. I'm going to bring the 80 over to the right by subtracting. That leaves me 20. And it turns out when I divide that x is equal to 4. So let's answer the question. How much pure alcohol? 4 liters. All right, so now you have a fully complete problem on your page. If you haven't written anything down, I'll leave that right up there. Example 4, same thing. A chemist wants to strengthen a mixture from 10% to 30%. How much pure alcohol should be added to 7 liters of the 10% mixture? I'm just going to give everybody a nudge. We're going to put the information in the picture, and then I'm going to give you a little more time to finish from there in case you're struggling. So what do we start with? What's the percent that I start with on this one? Okay, we start with a 10% mixture. And how much of that mixture do we have? Okay, I've got 7 liters. What are we adding to that? Again, it's pure. Okay, so again, it's 100%. How much pure alcohol am I adding? Again, I don't know. Okay, so the setup here is super similar to what we just did, so that you get the opportunity to run through it and process it. And what do I want to end up with on this problem? Okay, I want to end up with a 30%. Thank you. And what's the volume of that going to be? 7 plus X or X plus 7. Either way, doesn't matter. I'm going to give you another minute or minute and a half. Make your equation, solve some of it, and we'll see how much we do need. All right, what's my first term going to be when I look at how much alcohol is in that first box? It's going to be 0.1 times 7, which, yes, once you do that multiplication, it's going to turn out to be 0.7. And then what's my second term going to be? 1.00, that's my 100% written as a decimal times X. A percent times volume every time. And then on the other side, it's going to be 0.30 times X plus 7, percent times volume each time. So the rest of this, again, I don't think this is the challenging part. That's difficult right there to set that up and get that going. Okay. So 0.3 times X is 0.3X, 0.3 times 7 is 2.1. I'm going to get all my X's on the left, or you know what, I might as well just go ahead and do the decimal thing since I seem to have a lot of decimals going on here. I'm going to multiply everything by 10. So that gives me 7 plus 10X is equal to 3X plus 21. When I bring the 3X over to this side, I get 7X. When I bring the 7 over to this, I get 14. And when I divide, that gives me 2. And so how much pure alcohol in this situation? I would add 2 liters. Questions, comments, or concerns before we turn the page and wrap this up? We're almost done. All right, last page of Unit A. Example 5 gives another type of word problem that you might see some of. I'm going to read through this. We're going to think through it together. It says a technician runs a copying service in his home. He paid $3,500 for the copier and a lifetime service contract. Each sheet of paper costs 1 cent, and he gets paid 5 cents per copy. X is the number of copies that this person is making. All right, so here's the first thing. Let's express our cost as a function of X. We're going to create an expression that represents the cost for this person running the copying business. Okay, so what are the components of cost? How much is this person spending? Okay, 3,500. Does the 3,500 depend on copy? How many copies you make? No, the 3,500 is just that. Whether you make 1 copy or 1 billion copies, that is it. So 3,500. What else is this person spending? Each piece of paper costs 1 cent. Does that depend on how many copies you make? Yes. So what am I going to do with that 1 cent and the number of copies? Not going to subtract, well, not going to subtract it. What'd you say? We're going to multiply. So what I'm going to do, the technician paid $3,500 no matter what. And then to that, we're adding additional cost of 1 cent for each sheet of paper. So that's 0.01 times X. There's my cost. My revenue. How much money is this technician making? 5 cents a copy. Yes. So what is that going to be? How do I express that? Okay. 0.05x. Great job. The break-even point. Break-even point is where your costs and your revenue are the same. Okay, so we want to know how many copies does this person have to make until they start making money. So here's what I'm going to do. I'm going to take my cost, my 3,500 plus 0.01x, and I'm going to say, when is that equal to 0.05x? When is the amount of money that this person spent equal to the amount of money that they're making? Because then they want to make more copies than that. Okay, so what I'm going to do here is I'm going to just put the 0.01x over onto the right by subtracting. So I get 3,500 is equal to 0.04x. I'm going to divide both sides by that 3,000, excuse me, I'm going to divide both sides by the 0.04. And when I do that, we get that X is equal to 87,500. That's a lot of copies, but it doesn't take too long. So that's just a simple cost revenue analysis. You're going to see a couple problems like that where you have to set up your function and then set them equal to each other in order to find the break even. All right, we're going to end with just a couple of formulas. And then if we have a couple minutes left, I think a couple people had some questions they wanted to ask, and we can definitely get to those. So example 6, we're going to solve this formula for A. There's a couple ways we can approach it, but in either event, I see that there's a fraction, and I hate fractions. I don't want to deal with the fraction. So what am I going to do first in order to get rid of that fraction? Let's multiply everything by 2. So I've got 2 terms. I got the left and the right. So let's multiply both sides by 2. So a 2 over here, and then a 2 over here. So on the left, when I multiply by 2, what do I have? 2a. 2 times capital A. When you're solving a formula, case does matter. We're solving for lowercase a. On the right side, when I multiply by 2, what happens to the 2 and the 1/2? They cancel out. And I just have h times a plus b. At this point, you have options. Doesn't really matter which way you do this. So I will show you both just in case you like one of them better than the other. Here's what I would do if I was doing this problem. I would say, okay, my goal is to get the a by itself. So what I'm going to do is I'm going to next move that h over. So I'm going to divide both sides by h. Okay, so I will do that. So divide here by h and here by h. So my left is now 2 capital A times h. On the right, after I get rid of the h's, I have a plus b. So if I'm solving for lowercase a, I've got one more thing to do. I'm going to subtract that b from both sides. And there we go. I'm done. The alternative is, instead of dividing by h right away, you see you got parentheses. Maybe you would have liked to distribute. That's an equally wonderful course of action. So I'm going to do that. So I've got AH plus BH when I distribute. So I'm going to bring the BH over by subtracting it. So 2 times capital A minus BH is equal to AH. And then you divide both sides by the H. So again, in both situations, I'm just trying to get the lowercase a by itself. One of them I chose to distribute. The other one I didn't. It doesn't matter. These expressions are equivalent. Either is equally valid. So last problem of the day, if you got any questions or any comments, concerns, anything we need to bring up, please do. Example 7, just go ahead and finish off that and solve that equation for capital L. All right, to solve this for capital L, what's my first step? What do I need to move? You could divide all that by 2. That would be good. I'm going to do this slightly. So if you divided everything by 2, then you have P divided by 2 over here equals W plus L, and you subtract the W. That's fantastic. I would accept that. I'm going to move the 2W instead. I'm going to move that whole term over to the left side of this by subtracting. So again, if you did it by dividing by 2 first, what you have is equivalent to what I have. Neither is righter or wronger than the other. So I've got P minus 2W is equal to 2L. Now I'm going to divide by 2 to get that L by itself. And there is my expression. If you divide it by 2 straight away, then notice, remember, division is distributive just like multiplication is. So I could take this 2 and divide it into both terms, and I get P divided by 2 minus, and then these 2's cancel, and you have W. So that's why those two things are exactly equivalent.